So this video is going to start on normal distributions and the empirical rule. Now this is often called the bell curve. So again, we've gone through this in class, but just to revise over it. There is a point in the middle of this bell curve which is symmetrical. In other words, there's a line that runs down through the middle, and this is where mu is. So this is your average. Now this bell curve represents what's called a normal distribution. A normal distribution is where they take a population and they try to break up the population, whatever it might be, 5 million people in Ireland, and they try to convert them into percentages, and we've got to look at the percentages. So there is 3 particular parts that you have got to learn for your course, and we're going to look at those now. So your mean or your average goes right bang in the middle. Then on either side of that you will have 2 other lines. You'll have a line running there and there. And these points here represent how far from the mean or the average they are, and they're represented by standard deviations. So for example, if you go from here to here, you have gone 1 standard deviation from the mean. If you move on to the next one, it will be 2 standard deviations from the mean. And if you move on to the next point, it will be 3 standard deviations from the mean. And they are the 3 that we are going to look at. It also works going the opposite direction. If you go to the left, you're looking at -1 standard deviation. You can go to -2 standard deviations, and you can go to -3 standard deviations. But when we're writing this, the way we often write this is this first number here is written as the mean plus 1 standard deviation. The next one here is written as the mean plus 2 standard deviations, and the next one here is mean plus 3 standard deviations. And then there's lines here as well. So we have a line running straight down through that, and a line running straight down through here, and then the same on the other side. Now what do these actually mean? Well, let's have a look. So if you are in this category here, running from here to here, so anything inside this, I'll try and fill that in as best we can. So this particular area here is called being within 1 standard deviation of the mean. This is 1 standard deviation of the mean, or the average. And that's what goes in there. There's a percentage of the population that is within 1 standard deviation of the mean. And for your course, the number you need to understand is 68%. So what does that mean? That means if your average IQ across the whole country is 100, a value of 100, your IQ points is 100, and you're told the standard deviation is equal to 10 IQ points, then that means 68% of the population will be 10 above the 100 and 10 below the 100. So 60% of the population will range between 90 IQ points and 110 IQ points, where the average is 100, because you're plus 10 and you're minus 10. And since your standard deviation is 10, this here is 1 standard deviation above the mean, and this 90 here is 1 standard deviation below the mean. There's 2 other data points that you need to know about, and that is this one here. So everything in this particular part here and this particular part here is going to be 2 standard deviations from the mean. So this is 2 standard deviations. In this case, because we're on the negative side, this is 2 standard deviations below the mean. This one over here is 2 standard deviations above the mean. And then finally, the last one is in here, in yellow. And of course, there's percentages to be put in here as well. So if you're in the blue section, you're 68%. And if you're in the purple section, so it is 68% running from here to here. That's 68% of the population. But if you move out to the purples, and I'm going to draw it up here because there's not enough room, and I'll just continue that line all the way up, this line all the way up. If you go in here, from here all the way across to here, that includes the 68%, but it also now includes the 2 purple ends. That covers 95% of the population. And finally, if you go to 3 standard deviations from the mean, this will cover 99.7%. Now, there is other percentages, there is other standard deviations, but they're not part of your course. This is just 99.7%. So, if we're looking at the example of IQ, let me just get rid of this here. Based on this graph, let's say we take IQ as in the middle here. What's that? So if your IQ mean is 100 points and you're told your standard deviation is 10 points, then anybody in here is going to be 110. Anyone in here is going to be 90. However, when you go up here, this is your mean plus 2 standard deviations. Now, if your standard deviation is 10, 2 standard deviations is 20. So your mean plus 20 is going to be 120. The next one, your mean plus 3 standard deviations, is going to be your mean plus 30. So this will be 130. And the same thing applies at the other end. So this is 90. This one here is going to be your mean minus 2 standard deviations, which is 80. And then the next one is 70. By filling in these numbers, what you're basically saying is if you go between 3 standard deviations all the way over to plus 3 standard deviations, that means 99.7% of the population. Now, where am I getting that from? I'm getting that from up the top here, which is between the points on the far left and the far right. So 99% of the population have an IQ of between 70 and 130. From this diagram, I can also make another assumption. If I take 95% this time, 95% again of the population have an IQ, just move down a bit of space, of between whatever our 2 standard deviations are, and that's moved slightly. So that's between 80 and 120. And then you can also say 68% are between 90 and 110. So that's an introduction to the bell curve and normal distribution. There's not a huge amount more to it, but you do have to be able to, if you're given the mean and if you're given the standard deviation, you need to be able to work out the mean plus 1 standard deviation all the way up to the mean plus 3 standard deviations. The maths is actually very simple. It's just trying to understand what's happening. So let's have a look at a quick example. And let's say, I'm not going to write out the full thing, but let's say we're talking about the height of students in a school. Okay, so we're dealing with height. We're dealing with students, and we're told the average height in the school is 158 centimeters. And again, that's your average or your mean height. You're then told that the standard deviation is 10 centimeters. Then it will say to you, the empirical rule says that 68% of students, or 68% of a normally distributed population lies within 1 standard deviation of the mean, and it will ask you what range of heights are in this. So for example, you need to be able to do this. You need to be able to say 68% of the population is either 1 standard deviation above the mean, or it's 1 standard deviation, sorry, slight mistake there, or it's 1 standard deviation below the mean. 68% of the population of the school will be in that. So we do that. So we do 158 plus 10, or we do 158 minus 10. So that gives us 168, and it gives us 148. Now again, try to think what this means. This is a range. And that means 68% of all people in the school are between 168 centimeters and 148 centimeters. If you move on to the next value, which is going to be 95%, that will cover 95% of the school. That is the average or the mean plus 2 standard deviations. And it is the average or mean minus 2 standard deviations. So that's going to be 158 plus 20. And this is going to be 158 minus 20. So now we're dealing with bigger numbers. We're now up to 178 centimeters, which is very tall. We've got 138 centimeters. So this here again is the range. And this covers 95% of the population. And this makes sense. Because we've increased the range, we have much taller people here and we've much smaller people here. Therefore, we're now covering 95% of the school. And then the final one you've got to be able to do is 99.7%. And this one here is the average plus 3 standard deviations and the average, minus 3 standard deviations. So that gives us 158 plus 30, and it gives us 158 minus 30. So that gives us 188 centimeters and 128 centimeters. And in this one, the range here is 99.7% of people in the school are between those ranges. Now, what about the last 0.3%? And this is an important part. Well, that 0.3% includes the ones that are taller and shorter. So that means 0.15% are taller and 0.15% are shorter. And these are people that are, really, really tall. They're outside the norms of what is tall. These are people who are 6'7" and 6'8" and 6'9", and shorter people then who are, 4'10" or 5 foot. So that's what those numbers are there. So that's a quick explanation as to what you need to be able to do with the empirical rule. You have to understand the percentages. You have to know how to find the ranges with the mean and the standard deviations, and you need to know this bell curve. Okay, I hope that helps, and let me know if there's any questions.